Thank you, Tom. Thank you very much. That was very nice introduction. I would say not just about me, but also about the CDSE, or as we call it, Copernicus Data Space Ecosystem. So, good morning, everyone. Again, thank you very much for joining this morning session on openEO, which is the open source component of Copernicus Data Space Ecosystem. But for those who were not yet introduced to the Copernicus Data Space Ecosystem, let me try to move the mouse first. Sorry, I was doing it the other way around. Okay, for those who are not yet familiar with what CDSC is, I have included a slide to quickly introduce you or to provide you a definition of what we aim to do with CDSC. But my presentation would mostly focus on what is openEO, what are its key features, why should we promote openEO, which is an open source tool for Earth observation data analysis. And yeah, while I'm here, please feel free to raise questions on why it should not be used, or if you think that, okay, this is very nice thing, but these are the features we want to see in the upcoming days in openEO. So they all are very much welcome. So, but before that, let's take a step back and reflect on how remote sensing data set can be useful for several applications. It can be as a land monitoring related application, ocean related application, or there are a lot of data set out there that is also useful in monitoring land surface temperature. These are also helpful in different scenarios, whether it be with regards to disaster monitoring or with regards to other related application. When talking about disaster monitoring, we cannot forget about the radar data sets that are very much vital in these applications. Understanding the importance of these remote sensing data set, but still realizing the complexity to use this data set, that is where the Copernicus Data Space Ecosystem came into the scene. So a simple definition to CDAC would be that it is a user-centric platform that aims to provide different data set, mainly the Copernicus data set, which we also call as Europe's eye to the Earth. So all the Copernicus data set that are open and freely available, we are trying to bring it at one point, which is CDSC. So in future, not just the Sentinel satellite missions, Sentinel-1, Sentinel-2, 3, and 5P, but also other missions will all be available here as the first point of data. There are also Copernicus contributing mission data set. In addition to that, there are a lot of other value-added products available within the ecosystem. This was all about the different open source data sets that's available there. But in the ecosystem, we also wanted to introduce with tools and resources that could be used by researcher or big projects, or even a startup company who are looking towards having a bigger impact in the remote sensing or the Earth observation domain, to use the tools and resources that's given by the European Union or that is available within. And while we are talking about the bunch of data sets that's at the moment available in the ecosystem and that is continuing to add on within the ecosystem, we cannot forget about the tools that are also available there. Initially, these tools always scattered in different locations, and the problem used to be that, okay, in order to access Sentinel Hub API, I do need to go and have a Sentinel account. For openEO, maybe I need to have a OIDC or the EGI check-in account. And similar was the case with the catalog API. So we wanted to simplify it, and you will find all this within the CDSE as the API collection. But in addition to that, the browser, which was previously known as Sci-Hub browser, is now available in CDSE as Copernicus browser. So I assume you, being a user of the remote sensing data set, have already seen these changes. So those applications are already there. However, in CDSE, there are a couple of other interesting applications, which I will also cover up in my slide, which could be very much interesting for you to try out or to use it. Having said that, one of the very important API in the ecosystem is the openEO API. This is the open source component, or one of the open source component of Copernicus Data Space Ecosystem. And this is the image that we really like, and we show it everywhere whenever we want to introduce what is openEO. So the basic idea of openEO, or as we say within our team, is like This is one entry point. So it is a open source API, basically, in order to access data set, not just from one backend, but using the same method from different backend. If I try to relate with how I used to do back then when I was, when I am still a geomatics engineer, but when I was learning how to do remote sensing analysis, okay, I want to use Google Earth Engine. It has certain set of data set. I prepare my workflow, I log in, I do whatever needs to fill in the process, and I prepare my algorithm. But now it didn't have the data set that I wanted to use. It was provided by a separate platform. Then I had to again completely move to another platform, redo the whole wheel of creating the algorithm, since the algorithm that was developed in one platform was not interoperable to another one. So this was kind of a hassle that I was going through. So that is what we were trying to simplify with openEO. So the workflow that is developed in openEO, it runs in a cloud native environment, and they are already, during the build-up process, the openEO takes care of the scalability and providing it as a cost-efficient service. By service, I will also try to cover up in my tutorial session this afternoon, but also I think I have a couple of slides to showcase on what we are referring to as service, not only the algorithm, not only the data set, but there are also something called user-defined process that we call as service. These are on-demand service, on-demand process that could be used. So that was a long description about openEO. What makes it unique are its support to the FAIR principle. The first key feature that I want to highlight with openEO is that its capability to handle this data set, this remote sensing data set as data cube. So when these data cubes are connected or combined together with built-in process that's already available in openEO, then you get something like that building blocks, which we also call process graph. This process graph are actually simple JSON representation, so you can easily port it to different platform or different backend where you want to do the processing. One thing to note about openEO workflows are they follow lazy evaluation, meaning the workflow is not executed unless it is explicitly requested to. While we talk about process graph, so the one that you saw, JSON representation, that was created by dragging and dropping the building blocks. However, the same JSON representation can also be obtained with Python or any other preferred client library that you would wish to use. And it would be completely independent of underlying technology. And same is with regards to its nature of what I call backend agnostic. So it can, the algorithm that you develop with one specific backend, by backend, I mean the data set where the provider where you get the data, or also the infrastructure where you want to run your workflow. So you develop one algorithm there, then it can be easily ported onto a different backend. That is a unique feature of openEO's backend agnostic nature, and everything is done in the cloud infrastructure. Currently, the backend that we support or that supports openEO is ESA's cloud openEO platform, that is openEO.cloud endpoint. The other that is provided by the ecosystem itself is the openEO.dataspace.copernicus.eu backend. This is what we call CDSC backend. Then there is also Terrascope backend, which is openEO.VITO.bay. Terrascope is a platform similar to CDSC, but at a smaller scale for Belgium users. But yeah, it does include a lot of other products which cover globally. So these are three backends. Recently, an interesting component that has been added is the federated endpoint. So with that, you can not only access the data set from CDSC, but also from Terrascope, and you can use the resources among any of this with single endpoint, that is openEO federation.dataspace.copernicus.eu. Next feature, and I would say arguably one of the important one, is the algorithm, the workflow that is developed with openEO are scalable. And in support of that, I wanted to show you an example. This was an algorithm developed by a researcher from University of Twente, and they wanted to enlarge this to a larger scale. They wanted to use it for a larger scale. They wanted to process the whole Africa at one go. So we were testing of how it goes with OpenEO, and we were able to generate this 2019 HANPP product within 25 hours in a single OpenEO batch job. So that already highlights on how scalable a workflow can be. The same workflow can be narrowed down to a small scale, but is easily handled at a larger scale. And the whole backend and the backend itself, whichever backend you choose, will handle the parallelization task, allowing researchers to focus more on the scientific aspects and not dealing much with the high performance computing if you are not interested in this one. However, with OpenEO, there is also a feature to deploy your own backend. I won't be going in depth with that one, but that is also possible. That is when you want to have your own individual backend. I think that's not what I'm mentioning over here, but this is one example that I wanted to show you what was done with the CDSE backend. Last but not least, a very important feature that we support in OpenEO is the trend of code reusability. So we know that a lot of work has been done in the remote sensing domain, but they often remain underutilized, as a result of which they are again repeated. So that is what we want to avoid. And that with that, we have this concept, which I also mentioned earlier, what we call user-defined process. So these are the algorithm that you develop, but this time a parameterized algorithm that you save as a user-defined process, which can be used by your team members. Or if you want to go to a wider scale, then we also have platform like Apex, which is another ESA initiative that's on play. And from CDSE, we have OpenEO Algorithm Plaza. So each individual here, as well as everyone in the remote sensing domain, they are invited to share their algorithm in the OpenEO Algorithm Plaza or Apex if it suits the criteria. Because for Apex, there are some criteria that needs to be fulfilled. But for Apex, everyone is invited to share their algorithm. The only requirement is that it should follow the OpenEO standards. These were about OpenEO and its key features. But to show you some use cases that have already used OpenEO and have also proved its validity or validated its usefulness in their workflow, I have summarized a couple of them. For those who attended LPS, they might also relate to these slides that I'm going to show. Nevertheless, I will describe each one of them, so you won't be missing out anything. But I want to start with a simple use case that is also available in the GitHub repository of OpenEO, where we provide community examples. These are simple examples to help users get onboarded in using OpenEO. So in this use case, what we wanted to show was how you can simply fetch the data set from CDSE. In this case, we are trying to replicate a workflow that was there, I guess, in EO Society example, which used Snap Toolbox. So in this case, we didn't want to go to downloading of the data set and performing each steps in the toolbox itself, but we wanted to do everything in the cloud environment. So what we showed here is like you can simply access the data set of your area of interest for the temporal extent that you are interested in a single line of code. And using the built-in process that's there, with OpenEO, you can perform basic function, such as in this case, I use SAR backscattering, and there was aggregation process. So these are a couple of function or process that's already defined by OpenEO. And if it is not defined by OpenEO, then there is a possibility to bring custom functions. And that is what our tutorial session in this afternoon would focus on how to bring your custom function in OpenEO workflow if it does not already have this built-in function that would support your workflow. The output is stack compliant, meaning you can share it as a stack collection if you publish it somewhere, and you can reuse again in your workflow. And I think stack standard is something that we want to move ahead in our future. This was a simple use case. Moving on to some advanced use case, which is LCFM. This is also an ongoing project, but I thought why not to highlight here, because it also showcase on how how the workflow was easily adapted in OpenEO, and it was scaled up to a global scale. The map that you see on the right is annual median composite of Sentinel-1 that was fully generated using OpenEO. And in this one, the challenges that was there was how do we handle large volume of data set? Do we download everything to our own machine, or how do we do that? So that was addressed in this case. Eventually, the idea of this project was to provide a service, user-defined process again, so that each individuals can reuse this service and use for their own workflow. So the on-demand service is coming soon in future. I think they have a release this September. So tune in with the Copernicus webinar series. I think that's end of September, I believe. So that was one of the use cases that highly showed the code scalability. Another project that was also a hit in LPS, which is ESA's World Serial Project. This also made use of openEO workflow. It made use of openEO workflow not only in preparing the features, because it had direct access to all the CDSE collection as it was done in LCFM, but also it utilized the feature or the processes, built-in process of openEO. In addition to that, there were Presto models which were something outside openEO. So what it did was it used this concept of user-defined function to bring into the workflow and prepare this more interesting model that is now displayed out there as a user-defined process, again as a service, and is shared among the team so that they can prepare their own cropland maps on demand for their own region for their interest of temporal extent. To show you how does the user-defined process look like in a visual way, I want to show you an example in Apex algorithm catalog where this user-defined process of world serial is onboarded. And I hope it will play. I think it started playing. So this is an algorithm catalog from Apex, and there are a list of openEO algorithms as well as others, one of them being world serial. So the whole algorithm was, it was compiled with openEO, but in here what you see is a simple interface where you select what do you want, in which extent you are interested in producing the output is, that is the cropland map, and specify the temporal extent. Then you say which output format do you want? Do you want in a GeoTIFF, which openEO gives as a cloud optimized GeoTIFF, or you want in a NetCDF format? This whole thing can be monitored in a graphical user interface platform of openEO, which we call web editor. And everything was done in cloud. You get the result for your own setup. So this is an example of how user-defined process could be beneficial or useful in such scenarios. As I mentioned earlier, in Apex, there is a requirement that if you want to onboard your algorithm into Apex algorithm catalog, it highly supports ESA projects. So if your project is not a ESA funded project, then it could be difficult to onboard in Apex catalog. But that is where we showcase or we encourage users to come up with the openEO Algorithm Plaza. So this is a platform open to everyone to share their algorithm, but not only sharing the algorithm. I call it as one-stop shop, because here you can not only drop your products that you want to share it with a larger audience, but you can also use the products that's showcased in here. As you can see, World Serial is also part of this platform. So you can use World Serial from this openEO Algorithm Plaza or directly from the algorithm catalog, Apex algorithm catalog. And another interesting part is I showed you in a web editor view. However, you can also run it programmatically. Let's not forget that openEO supports interoperability, so that should not be a problem in loading the workflow. I also wanted to show a use case that is already demonstrated here. If anyone is interested in working with agriculture fields and everything, this is one of the service or user-defined function which is completely adapted in openEO called CropSAR that makes use of Sentinel-1 and Sentinel-2 in order to provide you with the biopar products. So this is one of the service that's available there, and there are users that are actively using this service. That was about OpenEO and the use case that have used OpenEO. Hopefully that encouraged you as well to learn about OpenEO or to move towards a direction saying, okay, it could be an interesting platform to use. Let's start. So with that, I want in my slide, at least in this section or in this morning session, I will only show what an OpenEO workflow would look like. But to go in a bit detail of each step, I would like to invite you to join me in this tutorial session this afternoon at 13:30. So a general OpenEO workflow in most of our case is, this is how it would look like. There will always be a first step to authenticate yourself. By authenticate, I mean from which backend you want to access the data set, but also to process your workflow. In this case, I'm showing an example using Python client. Please feel free to use it with R or even using in a web editor. So in the first step, we are connecting to the Copernicus Data Space Ecosystem backend, authenticating ourselves there. And in the second step, as you can see, I'm just saying, let's load Sentinel-2. I don't want to download the entire tile just to have a visualization of how Wageningen would look like for an RGB image. I just say, get me this, and this would be the area of interest, whether it be a bounding box or the feature collection that I pass in. And in this case, yeah, as I'm interested in RGB, I just say, okay, I'm not loading the RGB, but these are the bands that I'm interested in. And in the next step, we'll be applying the algorithm. In this case, I'm showing you a very simple example of calculating the maximum of over a temporal period. And that is because there are some built-in process and max time or reduced temporal dimension by time is one of the function that's already available in OpenEO. But there is also possibility to bring your own complex or even simple algorithm in the form of user-defined function within the workflow. And in the final step would be saying, okay, I have prepared this whole workflow which follows lazy evaluation method. So can you please run this for me in your cloud environment? Then in this case, I'm just saying download the output in a netcdf format. That would be a simple workflow of OpenEO. To break it down even more further, where I want to calculate a NDVI time series, I'm showing you now as building blocks, but programmatically it would be same. I load two collection. In this case, I'm saying two collection because I'm separately loading a data cube of these bands, and I'm separately loading another data cube calculating SCL layer because I want to perform a masking over the cloud. And these are a couple of steps that were involved, which not only involve masking of the SCL layer, but also resampling the data cube and finally calculating the time series of this data set. And at the end, I'm just saying, can you please provide me this as a JSON file, or you can also get a CSV file in this case as it is a time series. That was more or less about how you can use OpenEO. And yeah, there is always a community example. We try to remain up to date with it. If it is not there and if you run into issue, then please feel free to post it in the forum. We try to be as responsive as possible. So we have kept ourselves a deadline of 3 days. So you should receive an answer within 3 days. If not, then please feel free to mail us directly either in the OpenEO email channel or even in the CDSC support system. That was more or less about OpenEO. While leaving the floor, I want to quickly again go back to the things that I mentioned. So with OpenEO, which is a standardized API, we want to avoid this lock-in thing and also increase the discoverability of the algorithm that's out there. It supports different client libraries. At the moment, we do have example with Python, R, and also JavaScript. But yeah, everyone, if they like, I think there is also somebody here from Julia who are currently interested in using OpenEO for Julia, then please feel free to use it and let us know. Since it is an open community, we invite you to support us as well in that domain. Having said that, yeah, it is a cloud native approach. With CDSC, we try to promote everything being worked in a European infrastructure. but you are welcome to try it in your own infrastructure as well. Having said that, I would like to emphasize on what the summer school was more focused on with regards to the FAIR principle and open source component. So I would invite you all to support us in this open source initiative. Thank you everyone for your kind attention. I would like to thank you on behalf of my entire consortium.